Hey, Robert.
Hey, Yaron.
Hey. So last week we started talking about this book that we both read and really enjoyed called Chip War, about the semiconductor industry and the really the creation of the semiconductor industry. That's part of what the book is about. It's about how this industry was created. And I think that just that those early days and the story of how semiconductors were first developed and then mass produced and then became specialized and then became super specialized, and it is a great story about ingenuism. It's a great story about markets, ingenuity, connection, and all of that, right?
Absolutely. I mean, if you want the most important story of the 21st century, it starts in the 20th century at Bell Labs with the invention of the transistor. And anyone who's interested in the very early years, Chip Wars is not that book. It's about chips, not transistors. There's a book about Bell Labs called The Idea Factory. That's an excellent book that we talked about. Don and I talked about a year and a half, 2 years ago. And that's definitely worth reading. But what's interesting about Chip Wars is it takes you past the beginning, that initial invention and rapid growth of capabilities inside of semiconductors to have transistors work better and to put transistors onto an integrated chip. Those are all huge advancements. And then it just became Moore's Law. And Chip Wars is really about Moore's Law. And everyone probably knows what Moore's Law is, but it's basically the idea that the number of transistors on a chip will double every 18 to 24 months. And if you understand exponential growth, you say, well, that can't go on forever. And in a literal sense, it can't. Forever is a long time, though, and none of us will be alive when forever rolls around. So it's really the way to think about it is in our lifetime that could happen. And people have been saying it won't for, gosh, the first time I heard that was in the 90s.
Yeah, 3 decades now.
And it still is. And there's no reason to think it'll stop in the 2020s. And there's been a lot of innovation, and it's very similar to, in a lot of ways, the invention of the original transistor, where there was a lot of experimentation. The original transistor was a point contact transistor. It had little prongs sticking into the silicon, and then Shockley invented the junction transistor, which made integrated circuits possible. And then we just were off to the races, but there was a lot of experimentation to make it actually happen. Shockley was a theorist, and he had the idea of why the junction transistor would work, but then you had to make it actually work and then make it smaller and smaller and smaller. So a lot of experimentation, a lot of failure, a lot of learning. And a single company, a company like Intel, could do the whole process from the design to the figuring out actually how to make it work to the mass production in an economic scale. And then we got to something else. And Chip Wars is a lot about the something else. And it's a side of ingenuism that I think we have really not thought about as much, is what happens when the knowledge gets so complex that it's impossible for one person or one small group or maybe even one large group to actually manage all of it and continue to advance it. What happens at that point where connection doesn't just become a benefit, which has always been our position, but it becomes a necessity?
And it's interesting. There's something about economies of scope, or diseconomies of scope. That is, there's a point in which trying to do everything in-house probably becomes impossible or really, really hard. And Intel, I think, discovered that, but discovered it a little late and lost a huge amount of competitive advantage as a consequence. But I was just reading an article about Apple. And Apple seems to be going in the other direction in some regards. In a sense, it's going back to its roots. In a sense, it's going in the other direction. So today, we have an iPhone, or let's say the first iPhone. The first iPhone, Apple basically designed the iPhone, but the chip was made in one place, and the communication chip was made in another place, and the glass was made in another place, and everything was made, and not just another place. Other companies in other countries were making it. And what's been interesting about Apple is that over the last decade and a half, they've been bringing everything in-house. That is, today, Apple designs the chip, and it's just about probably the next iPhone will have a communications chip designed by Apple. And now I just read a story about Apple is actually building the glass that's going to be in the Apple Watch and in the iPhone and the iPad ultimately. So the glass is going to be Apple designed. And I'm, just me thinking aloud, I wonder if Apple can cope. That is, I wonder if the idea of this bringing everything in-house is going to be ultimately undermine Apple. So far, they pulled everything off. So it's hard to argue against anything they do. But with chips, it certainly has fragmented. Everything is being devolved. So that you've got hundreds and hundreds of companies doing different pieces in order to ultimately get that chip coming out of TSMC. Okay, I always get these wrong.
TSMC. But you make a great point, because the iPhone is very complex, but its rate of advancement isn't like Moore's law.
Yep.
New model comes out every 18 to 24 months, but the differences are fairly small. It's not a doubling of capabilities. Mm-hmm. And I think that it points to exactly the where you could and where you might be able to and where you won't be able to do everything yourself, in the sense of designing the chip. I think that makes a lot of sense. That's a core capability. Apple's strength is design.
Yep.
In terms of manufacturing the glass, I don't know so much.
I don't think they'll manufacture the glass, but they're certainly designing the glass and manufacturing the first pieces of glass. And then the theory is they'll outsource the mass production of the glass. But it is interesting, Apple Glass, who would have thunk? But I guess glass has become smart.
Glass has become, ever since fiber optics became a thing, glass became part of the modern world, which is funny. Originally, glass had two uses, either a window or a cup. And now it's become an integral part of all communications. And I think that if Apple were to try to integrate around semiconductors, it would be a complete disaster. I mean, it would obviously be a complete disaster, because you have to buy something, whether you're buying the manufacturing equipment, or you're buying the wafers, or you're buying the actual fabrication of the chips. There's something that you're buying. And if you try to do all of that, you come back to sort of the point of our talk today, which is, Apple actually could do it. Intel did it for a while. Apple would probably be the best position because they have so much money and so much resources. But what Apple could do with its resources and its people is just going to pale compared to what the planet can do. So connection becomes necessary, not absolutely in to accomplish something, but to accomplish what we now take for granted. It becomes necessary to connect people all over the world, because you have to have the very best glass, and you have to have the very best mirrors, and you have to have the very best lasers, and you have to have the very purest silicon and the best masks, and it just goes on and on and on and on. And at each level, it was really interesting to learn about how complex semiconductor manufacturing equipment has become, because the original equipment, it was miraculous, but it wasn't that complex. It was a lens and a light.
But even there, it was interesting how every step of the evolution. First of all, it was interesting how Shockley had this invention. He started his own company, wasn't a good manager, but from that one company, an entire industry sprung out, and all these veterans went and they started different companies, and then TI separately competed with them, and they kept innovating and kept learning from their competitors and kept improving. And then what was good about the book is it wasn't just about kind of the engineering of the chip. It was about the manufacturing process. It turns out that a big issue is not the science always, but it's, okay, how do you apply the science? How do you actually literally manufacture? How do you do it efficiently? The big thing about, he talked about the Japanese competing in the 1980s and how they could do it so much more efficiently and with so many fewer flaws. So fewer chips that they had to throw away, microprocessors. And that's how they dominated the industry for a while. That was the first kind of challenge to Intel when Intel didn't do well. And then Intel had to completely rechange its business model. I mean, what was so interesting about the book was that he covered all this dynamic. He did it. I mean, the book is well written, and he covers, and all of it happened like that. I mean, in my lifetime, less than my lifetime, we've seen all of this. We've seen Intel go up and down a few times. We've seen Japan go up, crash, China go up, maybe not, maybe crash, Taiwan go up and not crash. I mean, we've seen these changes so fast in the context of, and it's a testament to ingenuism. It's a testament to human ingenuity. It truly is a beautiful thing. And I think even most of us take it for granted, right? We turn on our products that have chips in it, and we don't think twice about it.
And I think about our kids. They're not even going to know what a blue screen is. Everything just works always, and it works basically forever until it's obsolete. But this gets to the point of when the first transistors were created at Bell Labs, Bell Labs was hoarding the applications for communications, but they basically licensed the patent out for something ridiculous like $1,000 to anyone who wanted to use it for another purpose. And so that allowed the ideas to diffuse very quickly. And first it was in the United States, partly that was because of timing, but it very quickly went to around the world, where different people were making things at different levels of the semiconductor fabrication process all around the world, but still aiming to be an integrated manufacturer. We've gotten to a point where if you want to get into the semiconductor value chain, you don't try, well, unless you're China, you don't try and do the whole thing, even though the recipe is out there.
Yep.
You pick a particular spot, and most people pick design. And that's why TSMC is so important and it's been so successful, is because they are the leader when someone comes up with a novel design, and they basically think first, go to TSMC for fabrication.
And the only people competing with them is Samsung, and so it's almost all in that part of Asia, and then Intel is going to try to catch up, but that's it in terms of that. So it turns out the fabrication, it needs economies of scale, but that every element that feeds that fabrication, design, equipment, all of that. So design can be fragmented. I guess equipment is very concentrated. There's basically one firm that does one machine, and then a bunch of others that do other machines. So it's kind of interesting how the business has separated itself. It tells you something about what benefits from scale and what doesn't.
And you have the feeding into TSMC, and I'm taking nothing away from TSMC, but their movement into higher density and higher density semiconductors has been driven by the semiconductor manufacturing equipment industry.
Yes.
They're not inventing new tools. They're taking those tools and then doing the absolute best to do high volume manufacturing, which is a whole different skill set. But you have to connect into this. If you try and do it all yourself, then even if you have the resources of an Apple or of a China, then your particular process is only going to be as good as your weakest link. And that's a severe problem when you have such a complex process with so many links. And so today, the idea is you get the best from all over the planet, and that can change and evolve and grow. And so it's more about collaboration than it is about knowledge diffusion. The knowledge is very concentrated. The manufacturing equipment is concentrated in what Scandinavian country, in Denmark or something?
No, it's all in Holland. It's all in the Netherlands, ASML. But of course, again, the lenses, it's Germany, because Germans have been making lenses for cameras for over 100 years, and you move from place to place. I think it's California for lasers.
Yeah, they bought the company in Southern California that makes the lasers. And so that's it. At each stage, you also have this tree that goes below it. So you've got the tree sort of below TSMC, and then each one of those has their own. Even in design, nobody writes their own software to design their chips. Apple isn't writing their own software to design their
I
new
think
chips.
the 3 design softwares for chip, all Americans.
EA software companies, and if you don't, you might use 1 or 2 or 3, but if you don't have that, you can't design a modern chip. You're basically starting back with where Fairchild was. And so this idea of collaboration is a completely different animal. And when the knowledge is concentrated, but concentrated in different places around the world, then you can't get the benefits of the best practices and the best technology unless you have collaboration. And that takes something that's quite different. I mean, connection is a part of it, but you have to have basically what we call the tenets of Ingenuism, which we don't talk about very much, but now suddenly realizing maybe they're even more important, which is trust, and I call it humility. You don't like that as much, but the willingness to say, if you're Apple, even though you're incredibly good at things, to say, we're not good at this, and we're going to let someone else do it. And then you have to be able to trust that supplier or that partner.
And trust is really interesting in this context, because that brings us really to kind of the geopolitical issue that arises. And I think that's where trust makes it. And that is, China and China's relationship with the rest of the world, and China's ongoing threat to Taiwan, where TSMC is. And of course, how are you going to gain that trust when you're threatening an island that you're going to occupy it, but you also want to buy their products, and you want to buy very sophisticated products? But beyond that, there's the issue, which I think complicates all of this and makes it a real geopolitical mess. And that is that these chips are not benign. They're not just a product that gets into televisions and consumer products and stuff. But as particularly we're seeing, we can see in Ukraine, and we can see in warfare whenever it's practiced, these chips are used in weapons, and they're the difference maker. They make all the difference. I mean, I really liked the section in the book, Chip War, where he talked about the 91 war in Iraq, where for the first time the world realized that the United States military was like at least a decade ahead of everybody else, because they had actually integrated chips into weapon systems, into missiles, whereas the rest of the world had not. And particularly China and Russia, this was a real blow to them. They might have had more tanks and more weapon systems, but they weren't smart. And the US suddenly had smart weapons. So that's the challenge. So you're threatening Taiwan. You're gonna have to use their chips and the weapons to blow them up. Are they gonna just sit quietly and say, "Oh no, we trust you. We'll send you those chips to blow us up that you want to blow us up with"? And then after they blow them up, what happens? The whole thing is,
it's fascinating. And the title of the book, Chip Wars, is a double entendre, because there's the trade part that people think about, but a lot of the book is about military applications for chips and how those applications financed a big part of the progress that now drives computing and consumer electronics, that we wouldn't be where we are except for the fact that there was this massive demand from the military that now is sort of a sideshow when it comes to volumes. But now we have the second level of war, which is the national. If you think about trust, you can trust yourself, you can trust your partner, you can trust your family, you can trust your village, you can trust your community, you can trust your nation, you can trust your.
Once you get the nation, you start, things start breaking down. I mean, look at trust in Congress, look at trust in Senate. Once you get to politics, already trust is breaking down. Never mind trusting the other guy's politician.
No, 100%. And each time it gets bigger, it gets harder to build this kind of trust. And arguably, a lot of these groups, these larger groups, like nations exist, or European Union, as opposed to nations, exist to create trust where it wasn't there before, to facilitate trust. And so ideally, if you're thinking about Ingenuism, both from a knowledge perspective, but also from and actually getting things done on a collaborative sense, you have to have global trust, like a global community of trust, which Most people think of, oh, well, we need a global government, but then you think about how little we trust our own government. Maybe that's not the solution. But if there isn't a solution, then we're always going to be below our potential. And so when China looks at this, I think they're right when they say, okay, well, we can't integrate with all of these other people because we don't trust them. So we need to do everything ourselves. What they're wrong about is whether that will ever actually catch up with the rest of the world. If you have 1/7 of the world's people, you are going to always be behind, no matter how smart, how hard you work, how focused you are on it. The larger the community that is attacking a particular problem, assuming that there's trust, freedom, and humility, that larger that community is, the faster it's going to progress.
But I think here the challenge is more complex for, I'm not defending China, but what the hell? It also goes the other way, right? Because China was not insisting on developing everything internally, but, over the last, certainly since Trump, but now with Biden, the West has basically said, you're not, now you're not getting the most advanced manufacturing. You're not getting the most advanced chips. You're not getting the most advanced anything. And China is in a position where they have two options, I think, and they've chosen the wrong one, I think, but they have two options. One, they could really work hard to regain the trust of the West and reintegrate themselves into the supply chain, if you will, and get collaboration and get all that. Or they can try to design it all themselves and do it all themselves. And I think they've chosen for now to do it all themselves. And you're absolutely right. That's impossible. They'll never catch up. It would be, I think, a global revolution in a sense of goodness, right? If China chose the other path. I mean, imagine a China that was committed to gaining trust and to building that trust, a China that said, you know what, we're never, if we ever unite with Taiwan, it'll be peacefully, but we're never going to invade Taiwan. And we're committed to global rules of trade and whatever. Wow. I mean, the explosion of economic growth, I think that the world would see would be, because you're right. I mean, so much, I think we're focused on chips, but if we extrapolate on that on other industries, it's less so in other industries, but I think still true, the trust and collaboration, are the engine that drives everything. And if we could get more of that, economic growth would just explode globally.
I think that would be huge. I mean, we've seen even in the most basic industries with Russia invading Ukraine that when you take parts of the world out of the global economy, it has impacts that ripple through to almost everywhere.
Yep.
And China is bigger and more important, and was more integrated. And I think you make a really good point that we're not here to blame China. I certainly believe that they could do more to build trust, but it is a two-way street, and no one has been a shining example of trying to build trust.
No, but there is an interesting, I saw an interesting story the other day about these, the drones that the Russians are using in the Ukraine war. They're buying them from Iran. So Iran is flying these drones. Iran has been under sanctions for many, many years. And yet the drones that are being shot down over Ukraine or exploding over Ukraine have chips in them, designed and manufactured, or at least designed in the United States. So they're getting chips. Chips get through. Chips are being smuggled into Iran one way or another. It's very hard to actually boycott these things when people are committed to getting their hands on them.
They're very small. The value is very dense. It's much easier to track oil tankers, and we can barely do that, if at all. To think that we can actually, without a formal blockade that lets nothing in, and you're searching everyone going through it. I mean,
but it is kind of crazy that in a war, with whoever we fight a war, it doesn't really matter. Most of the world is going to be using TSMC chips, no matter which side. The missiles are going to have the same chips in them, and they're going to be using software designed in the United States, even if they're bombing the United States. It is really fascinating to see. In a sense, our geopolitics hasn't caught up to the beauty of connection and ingenuism in the 21st century. That is, the world is amazingly connected. We're all using the same technology. We're all connected to one another. We're all collaborating in some way. There is collaboration going on in there, but the geopolitics is fighting that. And the consequence is, you know, where they are bombing each other, they're bombing each other with basically the products of that collaboration and that ingenuity. It's really, we have to grow up. The world has to grow up, catch up to our technology in a sense.
I agree 100%. I mean, we have a global market, and you know, a market is a phenomenal way to build trust, not, you know, blind trust, but trust where it actually works and people are doing what they say they're going to do and getting what they want, and on both sides of transaction. That's an amazing thing, and we don't have that sort of global cooperation. It looked for a hot second like we were getting there in the 90s, maybe early 2000s. And sadly, the pendulum has swung back the other way, but I'm hopeful, for what it's worth. Hope is pretty worthless, but I'm hopeful that the lose-lose proposition of Russia's invasion of Ukraine, it's a lesson that sticks with politicians, because I think we are in a world where, you know, outside of very small conflicts, there are massive losses on both sides. And I'm not saying there aren't net losses in small conflicts, there definitely are. But you could imagine, you know, if a mugger steals your wallet, they're better off, you're worse off. That there might be some level beyond that, but it's at the country level, when we start talking about wars, it's hard to imagine at this point. And yet, Russia invaded Ukraine, and China is talking about taking back Taiwan, and the United States is willing to meddle basically anywhere in the Mideast. We don't. I agree
Anywhere in the world,
100%.
really. Yeah, we learn nothing, and but hopefully we do learn. It's just it's not exponential like chip making. It bounces around. I think things get better, but they get better with a lot of noise. All right, so I think next time we're going to talk some more about China. There's an interesting article and actually an online book that talks about China and central planning and the relationship between China's success and its attempts at central planning. So that should be really interesting. And so looking forward to that. Thank you, Robert.
Thanks, Yaron. Talk soon.
Yep. Bye.